Okay, so finishing up with what we call the p-value approach. And the p-value has to do with probabilities. It's the probability of getting a test statistic equal to or more extreme than the observed sample value. And we're assuming that the null hypothesis is true. So let's say we want to find the p-value in a two-tailed test. Again, we're still looking at two-tailed test. We'll look at one-tails later. And let's say we're given a z-stat of 1.59. So that's negative 1.59 and positive 1.59. And what we're looking at are probabilities, and so we find this area using our z-chart, or we can use technology. I'll include that in our StatCrunch videos of how to find your p-value. So negative 1.59 gives us this value here, 0.0559. And that will be the same, so together, the area for the probability, we add those together. And I get a value of 0.1118. Now, how do we decide if we reject? Well, we're going to be given alpha. And if alpha is larger than p, we reject the null hypothesis. So if p is low, below alpha, HO must go. So let's look at an example on this next page. Here's our approach. They have it listed with 5 steps. Again, you don't have to number the steps. But it's going to start off a lot like the last approach we did with our hypotheses, our significance level and N, determining the appropriate test statistic. And so that's all going to be very, very much the same as what we did previously. Now, let's see here. So step 1, we are going to go ahead and remember we wrote these last time. This is the same example we did before. And our alternative. So nothing there's changed. Step 2. Oops, excuse me. We want to write our N, and we need our alpha, and that's going to be given to us. Step 3, we're still determining what our test statistic is. Again, we're going to use Z. So that's step 1, step 2, step 3. Looks very much the same as the other process. We're going to use Z because we know sigma. Now, since this is the same example as before, we can go back to that, and we'd find the test statistic the same. It's going to be 3, so I'm just going to cheat on that. So our Z was 3. That was from a previous example. And then step 4, we have that. We need to compute the p-value. Again, we know that alpha is 0.05. Now, to get our p-score, if this is 3, this is negative 3. Remember, we're going to find that area there. So for negative 3, it's 0.0014. And this may vary with technology. So on your homework, if it says to use technology, go ahead and use that calculator to find your p-value. Now remember, this is the same. And so our p-value, our probability is that total area. And remember, if p is low, HO must go. So that's our last step here is to determine whether or not we're going to reject the null hypothesis. Well, 0.0028 is less than alpha, and so HO is rejected. So you can see the connection between your two-tailed test and confidence interval. Once you found a confidence interval, you looked at a hypothesized mean, and if it didn't contain that, you did reject what we believed was true. Okay, here's a fresh example. We're going to use both approaches. I'm not going to repeat the common steps here. For both of them, we need to find H of O. And I'm not going to number these because that's not important. We believe that the mean diameter is 30 millimeters. The alternative would be that it is not. We need to know alpha. That's given to us. We need to know N. We are going to be using our Z-stat because we are given sigma, okay? And our Z-stat would be calculated the same way for either approach. It would be X bar minus mu over sigma over the square root of N. So that's 29.84 minus 30 over 0.8 over the square root of 100. And by my calculations, I got Z-stat equals to -2. Now, here's where things will vary. What we did for the first approach was we did our rejection and non-rejection regions. And so that's -2, and that's +2. And then, excuse me, I said that wrong. That's our test statistic. For this level, 0.05, your Z values, critical values, my apologies there, are these. Okay, so that would be that approach there. Again, all these steps are common. And we find that -2 is less than -1.96, so it's in a rejection area. Okay, now for the p-value, what we would have done is put the -2 in the 2. Let's find -2. -2 is 0.0228. The areas together, let's add those up. Which is the same as doubling them, okay, 0.0456. And this is our p-value. And what we would say is our p-value is less than alpha because this number is less than 0.05, and so HO must go. And we get the same conclusion. So you can see they're very, very similar processes, except up to here, we do our rejection and non-rejection regions and compare that. Here we take our Z-stat and get our probabilities and compare it to alpha.